Well, just about 3 years ago now, we started in this area called affective computing, which is designing systems that are sensitive to your sentiments, to your moods, basically, and then react accordingly. The whole field that works on this started just about really in seriousness 10 years ago. And I think we're at the forefront in many ways in terms of looking at what you do in reaction to a user's mood. So where we've made a contribution is we can tell what kind of mood you're in and we can intervene on your behalf. Maybe suggest something to do about it, like go take a walk, take some deep breaths, get up and stretch, those kinds of things, and some serious psychology interventions as well. And a new twist is using pop culture and social media to make you happier.
We are gathering data from whether it's your arousal levels or your heart rate, and what we're trying to do is communicate that back to people in a way that makes sense. A lot of times this data comes back in massive forms that people can't parse. So we feel like one challenge for us, especially for me as a designer, is how do we translate that data in a way that makes sense in the context that they're experiencing it and in ways that might cue other people around them if that's needed. So we decided to explore the notion of wearables and fabrics because that is something that is a part of our expression every day. So whether it's a little thing that I might wear that might light up, or it's something very dramatic and flamboyant, it doesn't matter to us as long as it's being communicated, right? Whether they're stressed or happy or. So those are some of the things that we're looking into.
And what are the benefits for a typical person of a machine being able to discern what emotions you're feeling at a given time?
Well, I think one of the biggest benefits is, especially in regards to stress, is that oftentimes we're so disconnected with the fact that we're experiencing stress because we tune it out, that these kind of interventions, whether it's a little poke on my shoulder or something lighting up, can actually get us to pay attention for a moment and maybe get past that bad habit. So we think that by getting involved might actually enhance people's well-being because they're so unaware of what's going on. Does that make sense?
And we've actually been able to show that in longitudinal studies, that we can make you less depressed, we can improve your positive coping strategies. And we think the reason we're able to do this so well and so accurately these days is because the ubiquity of sensors now, they're cheaper, they're smaller, they're more affordable, and they have longer battery life. They're still not perfect in that regard, and you just have to remember to put them on and take care of them and whatnot. But they can go places with you, so we can get very good using multiple sensors at discerning various states that we want to recognize, like stress.
Mm-hmm. And are you able to discern between the things that would make a heart rate go faster, like between someone jumps out at me and it's a different feeling when I'm scared than when I'm excited,
yes,
or I have adrenaline in my system? Are you able to tell the types of excitement and what made the heart go up or down?
So that's an excellent question. That's been our holy grail.
Yeah.
We're very good at getting arousal levels from low to high, but what we want to look at is valence from negative to positive affect. And right now, there are various ways, looking at your face, listening to your voice, where you can start to discern those things. You can even analyze text to help the system get better. Yeah. There's certain pronouns, for instance, you use more when you're in a negative affective state. However, we're really still in the early days of this technology and the science, and which signals are going to be the best to use in all contexts is still kind of it's a research problem.
And there are also things around, like even your phone, your accelerometer, your GPS.
How far you are
from
work.
Like, are you running versus not?
Yeah.
Right. So there are cues that we can borrow from other sort of sensing mechanisms that can start to tell that story and refine it. But that is something that is research. Like, we're trying to hone in so that we can be accurate about what we're trying to tell you.
And I suspect if your heart rate goes immediately up, that's probably, you got scared.
You probably got scared. Exactly.
So. Asa, you graduated from Parsons School of Design. Tell me a little bit about your background there and how that influenced your thinking.
So, I graduated with a bachelor's in graphic design, and it was towards the end of the 90s, and that was right when traditional design and digital design sort of collided, like two sort of incoming and outcoming tides. And it really led me into more interaction and web design. And I started in research actually in 1997, working in virtual worlds technology. So we were building 3D worlds and designing them. And so my design background came in handy because they were like, well, imagine this kind of world, or what would this kind of world look like? So from there, it's been sort of an ongoing evolution of skill sets and understanding how design can actually add to research from different perspectives and offering sort of new ways to sort of approach a problem.
And Mary, you have a PhD in cognitive psychology.
Yes, I do.
Tell me a little bit about that background.
Well, I was taught to look at how people, well, we actually did math models of how people process information, both visually, auditorially, how we make decisions. And when I came out of school, it was the perfect time to do human-computer interaction because it was one single user who had to look at the screen and make sense of it, learn it, memorize it, etc. Nowadays, you know, it's more social psychology might be even more relevant because you're looking at groups of people using many systems together. But nonetheless, because I learned all these paradigms for how we do work, we're able now in this new research area to throw a lot of the ways I did experiments back in the old days, throwing them at these new problems. Like for instance, when we used the fabric or the butterfly, we had to stress people out. Well, I know how to do that because I'm a psychologist, so we have lots of ways of examining those kinds of problems. We can really get you stressed out. I can make you depressed as well. And then we have, you know, classic ways for getting you back into a positive state as well. We never let you leave the lab stressed out, for instance. But so those paradigms that I was trained in actually have come in quite handy. And obviously we have big data because we have so many sensors we're using in this work. You have to know how to analyze big data as well. So my statistical background comes in very handy as well.
And what are your thoughts on how this will work in the future? Will you keep your data from your body sensors over a long period of time? Does that give you some benefit?
Well, the quantified self people really like that, right?
Yeah.
We were just talking today, I was just out at Northwestern the last 2 days talking to some clinical psychologists, and they really liked a system we built called AffectAura, which lets you reflect over your moods over time. And with the population that those psychologists work with, being able to reflect over what makes you happy and what makes you sad in your life is actually a very important tool for mindfulness and changing behavior and whatnot. So I think in everything we build, we probably will allow you to keep your own database, your historical database of your affect.
Mm-hmm. And can we talk a little bit about some of the devices we have? Or we see the dress behind you. We've got the butterfly in front of you.
Yeah.
Tell us a little bit about some of your projects and what they do.
Right. Okay. So this is our early prototype of MoodWings, which is we call MoodWings, and we used very simple nitinol wire, which actually moves when it gets heated. And so whenever the user was experiencing a state of heightened arousal, the wings would start to flap. And so this was like our first prototype. We also have a second generation prototype that actually uses speed of the wings to sort of also map the arousal levels. So the more excited you get, the faster the wings go. And we actually did a couple series of studies simulating a driving experience, and just seeing if users being aware of their heightened state of stress, how they would respond to the butterfly starting to move. And it turned out actually it did really stress them out. However, they actually performed better on their driving simulation. So there's something to be said for being aware of your stress when you drive.
Yeah.
Additionally to that, we have behind us Vesti. So Vesti is the actuated wearable fabric. And the notion with Vesti was really inspired by biomimicry and being able to borrow cues from nature, for instance, a porcupine or a dog or any kind of animal with fur. So when animals are excited, they often wag their tails, or they have mechanisms to sort of like emote that. And when they're upset, the hair tends to stand on end. So Vesti has been designed with about 40 motors inside it to flap and actually indicate happiness when it flutters in front and hackles when you're upset in the back. So it's very, very over the top, but intentional, because we believe that wearables isn't just about one thing. It's about an expression. It's about something that lives on top of us as we go forward. So borrowing from our fashion cues, fashion will be responsive. So.
And with Vesti, do you have anyone with the talent to actually make it do what they want, or is it just kind of, it happens?
Well, I think the idea is it would happen naturally, right? So basically it would be in alignment with the wearer.
Yeah.
And it would just be like an external emoting device. And often people say, why would I ever want that? Why would I ever want you to know what I'm feeling? And we think that there are audiences that could benefit from things like this, like autism, where emoting is challenging, or even how does a parent relate to a child, and there's a communication gap there. So if you have these sort of fabrics that could relate or respond, maybe that facilitates the communication. Or you might have PTSD, like where outbreaks are possible. How do we create mechanisms that could, warn family members, okay, there's going to be an eruption here. These are kind of things that we hope that even something as fanciful as this could maybe start to solve.
People might not realize either they are emoting whether they like it or not.
Exactly.
So
and I think
we make it obvious.
We think we might as well get in touch with that, right?
Yeah.
Because I think we suffer from the fact that we are not quite in touch with how we feel. So
it's called an honest signal because you can't, it's automatic, you can't really filter that out.
Yeah.
The other place we found it very useful to have something external to the user is, for instance, in a doctor-patient clinic visit, where the doctor maybe sees an expression of how warm or empathic he's being or she's being. The patient doesn't even need to see it, but the doctor can kind of monitor, maybe I'm talking too fast. We were working with the Seattle Cancer Care Alliance and some professors at the University of Washington to maybe train oncologists to be more empathic or to have a better bedside manner. And an external display is actually quite useful in that scenario.
All right, Paul, tell us a little bit about yourself.
Okay, well, I'm Paul. I've been a developer in research for about 10 years. And the last few years I've been in what we call affective computing, which we've been talking about. And it's probably the most interesting set of projects I've ever worked on in my life. When I started many years ago in computer science, it was, let's build an accounting system. And then I migrated into, let's build a web system. And, that was exciting. And now it's, whoa, let's program it so a butterfly flaps based on how excited you are. So it's gone in a direction I never would have guessed, and it's as interesting as it could possibly be.
So when do you become involved in the projects? From the beginning?
Oh, I'm involved, right from the start. Well, it depends on how you define the start. Oftentimes, Asta or Mary will come into my office and say something like, Paul, what if we had this react to, your heart rate? And I'll say, that's crazy. So maybe I'm after the initial idea, but I'm right at the start, yeah.
And what do you develop in?
It's a variety of things. It depends on whether I'm building firmware onto a custom board or whether I'm building an application on a desktop or on the mobile phone or whatever, or in the cloud. So I do a range from firmware, software, through C#, WPF applitions, up to Windows Phone applications, Azure Cloud Storage applications.
What are your biggest challenges with this work?
Oh, the variety. I can't be an expert in all of the technology from, writing sensor code to cloud code to phone code. So the variety is a challenge. That's also the glory of it and the big thrill is because every day it's a new challenge and it's a lot of fun that way.
So what are some of the things that you've worked on that surprised or delighted you? What were some of your favorite projects?
Well, I did mention the butterfly. The butterfly was a treat because, like I say, it was a surprise to work on it. It's not every day that somebody says, can you make a butterfly flap faster when you're excited? That is, and when you can get it to actually work, that's a treat. The vest also is a fabulous, that was so much fun. When you build something and then show it to people and it reacts to their own emotions when they're doing the demo and you've connected them to the device, that is a thrill.
So tell us about something that you've worked on that surprised or delighted you.
Yeah, I would definitely have to say the printing dress, the dress that I built with a colleague of mine, Sheridan Martin Small, was purely just exploration into a what-if scenario. What if your clothes could actually display your thoughts? Okay, and so we use sort of Twitter to kind of drive that. And it was something that we just thought we would do just to sort of start communications around a bigger conversation around wearables in the company. But what we didn't expect is for everyone else outside of the company to respond to that. And the attention in the press that I got was unprecedented, at least from my experience. I have never experienced that before. And it ended up in Bloomingdale's. So that was totally like unexpected. But what was nice about it was that it was validating in that people did resonate with it and they understood the concept of it, and that was the goal of it, was really just to inspire people to think beyond just a device, that sensors and actuators together eventually will change a lot of how we express ourselves in the future, or even understand things about ourselves.
So health sensing is a big topic right now. I mean, I'm wearing a Fitbit right now, and what are the types of things that you see this doing for people in the health sense going forward, and where do you think this will take us in the future?
So we just came off a big 4-week study where we had users do self-ratings of their moods for us, and then we used machine learning techniques to try to figure out their context using things available on the phone, but also their self-ratings of emotional state, and then we could go ahead and intervene, and we tried all kinds of different kinds of interventions to help them feel better emotionally and health-wise. And it turns out that we got significant decreases in depression and significant benefits from using machine learning to help teach them positive coping skills. So I think in the future, the masses actually are going to have access to information about their emotional state, and hopefully tools that they can learn to use to make themselves feel better emotionally, not just fitness-wise, but emotionally. Because, stress, for instance, is a killer. It really is a killer. The more I read about stress, I always get stressed out because it's just really so bad for your health. So I think the future holds a lot of promise in that regard. But if we talk about targeting populations of people who really need this, people with depression, people with serious stress problems, people who emotionally eat, PTSD, families with PTSD or ADHD, we can make a huge difference in their lives with some of these applications we're working on. So we're super excited about that.
I think also in terms of form factors, everything is going to get smaller exponentially. I mean, even 2 years out, we may not even see the sensors we're wearing. We already are aware of some of the e-tattoo work that's coming out of MC10. And so these kind of things just open up all sorts of crazy doors. And so it isn't going to be these chunky devices. I mean, soon enough, it'll be integrated into our person. So
they'll be embedded.
So I see you've got a MakerBot 2 back here. Tell us a little bit about that, and what are you using it for?
So we just got this recently. I was inspired to get one of these for a few reasons. One is because the PLA and the filaments, they can be bendable as well as conductive, and I thought there's a really interesting intersection between fibers and fabrics and these filaments. So I thought that could be some interesting explorations that happen there. But additionally, I mean, there are already numerous examples of dresses that you actually like attach together. Their shoes and hats. I mean, so as far as the accessory world goes, I mean, it's kind of endless. So I just have this innate fascination with the fact that I can just print something out just like that. Is kind of mind-blowing. It makes me feel like we're now in Star Trek, right? We're just like computer or coffee. So instead I would say computer or shoes. So I think it's just, it's for now, we're kind of at the beginning of looking into it, but it's been a lot of fun.
What are some of the other tools that you use typically?
So typically, I mean, I've worked with like conductive threads and fabrics and EL fabric and so all sort of soft circuitry to play with. I've also worked with a loom, believe it or not, and I've woven my own sort of interactive textile. So I think it's just whatever comes along at the moment that's needed is kind of the stuff we play with. So we're open. So right now we're doing conductive ink on acetate, and we're playing with some stuff like that. So
it's hard though. It's really hard to put these systems together. There's so many moving parts. You have to be an expert in sensors, signal processing, machine learning, materials, psychology, and design. It takes a small village seriously to do this work.
How durable are the items that you build? I mean, they're prototypes.
Oh man,
so you probably don't
to be honest, they're not very.
Yeah.
This is where we're at. I mean, things are crude, wires are clunky, things, power, the issue of power is a huge one, like batteries, and being able to continuously sense requires a lot of power. So there are all sorts of things that have to happen on those levels too to actually get us past the clunky phase. Do you know what I mean?
To run in one of our experiments, the care and feeding that's involved, we did one study with a bra, a woman's bra, that they had to keep taking off every 4 hours because they had to charge the board's batteries and charge the sensors they were wearing.
I forgot about that. And they tend to run hot.
Crazy.
So, so like I said, I mean, we We're still at early phases, but this is why it's really exciting, because we don't know what sort of impact's going to happen when something in whether it's the material sciences or the electronics, something changes that fundamentally.
Just inductive charging alone.
Yeah.
Exactly.
Yeah.
I mean, being
Exactly.
able to gather, energy and power from your body. I mean,
Yeah.
we're
It'll
going
happen.
to get there.
Yeah.
It's exciting.
Well, thanks so much for showing us this today.
Yeah,
you.
thank you for having us.